Alright, in this example we're going to solve the equation 4 sine theta plus square root of 3 equals negative square root of 3. The first step when solving a trig equation is to isolate the trig function involved in the equation. So let's start by subtracting square root of 3 from both sides of the equation. On the right side, we'll get negative square root of 3 minus square root of 3, which is negative 2 square roots of 3. Now we can divide both sides by 4 to isolate the sine function. Now this fraction is reducible, so we can cancel a factor of 2 in the top and in the bottom of the fraction. Now negative square root of 3 over 2 is a familiar sign value, so we can use our experience with the trig functions to figure out what theta needs to be. We know that if theta is negative pi over 3, then sine of theta will in fact be negative square root of 3 over 2. So negative pi over 3 is a solution to this equation. Now since the period of the sine function is 2 pi, we can add 2k pi, where k is an element of the set of integers. This set of integers represents all of the whole numbers. So if we add 2k pi, where k is a whole number, to negative pi over 3, we'll get an angle that's coterminal to negative pi over 3. So it'll also have a sine value of negative root 3 over 2 and be a solution to the equation. Now to find the second family of solutions, we can use the identity sine of theta equals sine of pi minus theta. It turns out that any angle theta has the same sine value as pi minus that angle theta. So we can find another family of solutions by taking pi minus our first solution, negative pi over 3. And we can again add 2k pi to get the all of the coterminal angles. Negative pi minus negative pi over 3 is 4 pi over 3. Add 2k pi. Define k as an integer. And now we've got our two families of solutions to this equation.